Hi.
Assalamu alaikum, Nasir, how are you?
I'm good. What about you?
Alhamdulillah. You didn't fix your camera yet?
No.
Why not? Are you actually not fixing intentionally or? Hmm?
No. Um. Next time I'll join from a different device, but it's just more convenient joining from here.
But you can't fix it. Your father is IT man, right?
Yeah.
So,
Okay. Next class, I'll probably have it working.
okay, I hope so, inshallah. Nasir, if you are ready, let's start. Today we are going to start a little bit more challenging questions with you. As I told you, we are practicing really beautiful questions. And if you solve these questions understandingly, it will really improve your critical thinking skill a lot, problem solving skill a lot, and also it actually helps you how to look at things or problems from different angles, from different perspectives. And suppose that, let's say, in the next 5 or 6 months, if we can solve like 500 different questions, okay? So that means that we will have learned 500 different ways to solve questions, hopefully, okay?
Mm-hmm.
All right. So now I'm not going to skip any questions. All right, we are going to solve every question here because it doesn't make sense without any reason just skipping questions. All right, Nasser, we in this paper we did the first 15 questions, and as I told you, the last 10 questions, 16 to 20, a bit harder, and 21 to 25, that's the hardest questions in this paper. Okay.
Mm-hmm.
All right, let's continue. Let's try to solve 10 questions today. Read the question.
16 players enter a chess tournament, which offers a prize to the winner in each of the upper section and a lower section. Winners of the matches in round one are placed in the upper section, and the players whose matches in round one are placed in the lower section. From this point onward, players only play these opponents in their own section and are eliminated from receiving a prize after their next loss. If there's no ties, how many matches are played in the tournament?
Mm-hmm. Did you understand the question, Nasser?
I think so.
Okay. Let me give you like 2 minutes, okay? If you understood the question, a lot of questions actually. If you understood, if it doesn't take too much time to solve this, okay? That understanding is, I think, the most important parts because it measures how you, what is it, understand things, right? Once you understand, solution part is only like maybe 10 or 15% of the problem. All right. Yes.
Wait, they are they if they lose they still keep playing, right?
Winners of the mass in round 1 are placed in the upper section, and the players who lose mass in round 1 are placed in the lower section. Then the first one, we are just grouping them, right? The good players in the upper section, weak players in the lower section. And from this point onward, players only play those opponents in their own section and are eliminated from receiving a prize after their next loss. So that means only you have one right to lose, right? And after that, the second lose, and you'll just actually be kicked out of the game. You got it?
Yeah.
Okay. The question is, altogether, how many matches are played in this tournament?
Is there 14 matches?
14?
Yeah.
No. Look, first, let's say this one is round 1, right? Okay, round 1, and round 2, and round 3. I don't know how many rounds. Let me just write here round 4. In round 1, right? 16 players played, right?
Yeah.
So how many matches are played here in round 1?
8.
8. Good. And now after that, we have 2 sections, right? Upper section and lower section. In upper section, we have 8 players, and lower section, we have 8 players, right?
Yeah. So
So in
4.
round 2, how many?
8.
It is 4 and 4. It is 8, right? In round 3,
4. 2 and 2.
2 and 2. It is 4. In round 4,
1 and 1.
1
Or
and 1.
1.
That's it. So why do you say 14 then? The total number should be 22, right?
Yeah.
Why do you say 14?
I didn't account for like the different rounds.
You didn't count the qualifying round? Or
Let's see. Let's see.
because it's asking the total number of games, right? Matches. Nasir, did you see your mistake or?
Oh, okay, yeah, I didn't count for the first round.
Yeah. Why not?
I just missed it. So for the first round would be 8, and I got 14. So like, 14 is like plus 8 is 22.
Okay. I mean, if you understood, all right. 17. Read the question.
Find the least whole number value of B plus C plus D so that 17 over 18 equals B over 3 plus C over 9 plus D over 18. Satisfy the two conditions. Each of B, D, and C are positive whole numbers, and each of the fractions B over 3, C over 9, and D over 18 is in lowest terms.
Okay, it's also interesting question. It says find the least whole number, right? Find the least, the smallest whole number value of B plus C plus D, so that's equal to this. Satisfy the two condition. What is it? B, C, D are positive whole numbers. Okay. And also each of the fractions are in the lowest terms, which means that in the simplest form, right? This is also an interesting question. Also try, I'll give you 2 minutes, okay? Then we'll discuss. If you get the correct answer, maybe we'll move to the next question. If not, we'll discuss it together, okay?
Yeah. If it says like each of the fractions in its lowest terms, that means
Yes.
like it can't be like a like 3/9 or like 6/18.
Yeah, that means that B, C, D are not multiples of 3, right?
Yeah, okay.
And the first step, did you actually write this equation on the right hand side? If you bring into a common denominator the 6, right? So here we have 6B plus 2C plus D should be equal to 17, right?
Yeah. Is it no? Can B and can B and D be the same number or no?
Yeah, why not? There's no any condition that they are distinct. If they're all different, then it must state that these numbers are distinct numbers, right? We don't
Okay,
have such
so
statement here.
I think um 151. So 7.
What is B plus C plus D, the least value of B plus C plus D?
7.
7. Is it your final answer?
uh, let me double check. Oh, 5.
It's 5, right?
Yeah.
Because first, if you start with this condition, the smallest possible value of B is, it is 1, right? Because B can be either 1 or 2, right? It cannot be 3.
Mm-hmm.
Also, it cannot be 4, because if it is 4, the right-hand side will be greater than 1. On the left-hand side, 17 over 18 is less than 1. So we have only 2 possible values for B. If B is equal to 1, so at the time, we have here 2C plus D. It should be equal to 17 minus 6. That's 11, right?
Mm-hmm. Yeah.
The 9 mid, huh?
Actually, yes, yeah.
Good. If C is equal to 1, D is equal to 9. That's not possible because 9 is a multiple. If it is 2, right, it is 2, D must be 7. It is not 3. If it is 4, right, well, D should be 3. Also, it cannot be 4. And what is it? It's 5, right? If it is 5, it is 1. In each case, then B plus C plus D, right? We have 3 possible answers. And 1 plus 2 plus 7, it is 10. 1 plus 5 plus 1, it is 7. And the second case is B is equal to 2. If B is equal to 2, then 2C plus 2C plus D, it should be equal to, how much is 5, right?
Yeah.
If it is 5, what is C? It is 1.
Yeah.
It cannot be 1, it's 2, right?
Yeah.
If 2, then D should be equal to 1. So at the time here we have B plus C plus D will be 5. Since it's asking the smallest possible value of this sum, that's why the answer is 5. Okay, Nasir, actually, in the questions in the first attempt, if you can get the correct answer, that's really good. But you are getting really close, but your final answer is not correct. But you're getting close. Really good. All right, let's continue. Question 18. Read the question.
Suppose 3x minus 4y equals 10 and 6x minus 7y plus z is 53. Find the whole number value of y plus z.
Okay, that's an easy question. I'll give it 90 seconds, okay? It's just about algebraic manipulation.
$33.
33. Good. So how do you write this? This one is 6y, 2 is a common factor. We can write as 2 times 3x minus 4y, right? So we have negative 8y. So here we have y plus z. That's equal to 53. And since this guy is equal to 10, dot, 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 y plus z should be equal to z should be equal to, what is it? 33. All right, very good. Here's the next question.
A rectangular box is 7 centimeters times 10 times 10 centimeters. Point A is the vertex and point B is the center of the front face as shown. Find the number of centimeters in the shortest distance from A to B along the surface of the box.
It's also a very interesting question. The idea is really beautiful. You give it a try, okay? I'll give it 2 minutes, then we'll discuss it, okay? Did you understand the question? I think it's clear, right?
Yeah.
You can imagine it's a kind of box. So we have a kind of ant, maybe. Is it ant or something? Okay, find the number centimeter in the shortest distance. Oh, we can just write ants. Okay, ants, it is on point B, so it's going to move to point A. So what is the shortest path that it can go from B to A?
Is it a rational number? Oh,
No.
okay. Yeah, so I see. Hmm. Is the answer 13?
Yeah. How did you solve it?
So like I like determined that you need to like find the hypotenuse of like point A to B, like make a triangle and find the hypotenuse. So I drew the box, but I made it like unboxed, like drew all the sides. So then I put like got the measurements and I found the hypotenuse.
Good. Because here, this question is the same thing as asking, right? If you just flatten it, so this cube, the front face and the right face, right? At the
Yeah,
time, we will have something like this. We'll have something like this.
yeah, that's what I did.
Very good. And that's the point here. So this one is, what is it? It is 10. And this one is, let's say, this 7. Maybe, say it's Okay, something like this. This one is 10, and this one is 7. And also this one is 10, right? So it is somewhere here. So now it's the same question as if, is it like moving from B to A. When it just flatten this box, you can see that the shortest distance will be the straight path, right?
Yeah.
So it forms a right angled triangle. So that AB will be equal to square root of, what is it? 5, right? This one is 5. It is 12 squared plus 10, 5 squared, right? 5 squared, so which is equal to 13. It's also a very beautiful question. Sometimes, Nasir, uh, if you suppose that there's a spider or ant, if they are standing in this kind of box in the center of the box, when they walk from B to A, they choose the shortest path. And the question is, how do they know that? Is it because of some kind of magnetic field, or how do they know that? That's really interesting. And maybe
Yeah.
sometimes, if you have time, you can search in the Google. How do they know that this is the shortest distance? And also for ants, they always choose the shortest path. Also bees, for example, when they collect honey, right? When they're coming back to their home, they choose the shortest path. That's very, very interesting phenomena in nature that Allah created. We believe for the creation, Allah created like this. But even for other people who does not believe, it's really beautiful. What is that phenomenon? Okay, let's continue with the next question.
The squares of two consecutive whole numbers differ by 79. Find the lesser whole number.
Okay, that's quite easy question. The squares of two consecutive, right, whole numbers differ by 79. You should find the lesser, the smaller of these two numbers. 1 minute.
Is the answer 39?
Yeah, that's
Right.
correct. So if you're talking about two consecutive numbers, if the first number is n, the second number should be n plus 1, right? It
Mhm.
says that the difference of the year squares. So squares and the year difference, that is 79. And now just using the, what is it, a squared minus b squared, right? That's equal to a minus b, a plus b. So we will get here 2n plus 1 is equal to 79. Now solving this equation, we will get n is equal to 39, which is the lesser of these two numbers. Very good. Next question.
How many of the first 10,000 positive integers contain the digit pair 43 in that order?
Okay, 2 minutes. Did you understand the question, Nasir?
Yeah.
Mm-hmm. Good. Yes, a bit tricky question, but it's a beautiful question.
Is it 3,000?
3,000?
Wait, no. Uh,
You know, this 1 to 25, if this is a competition, if you can solve this question, that means that you are a gold medalist. The first 20 questions, that is silver. Try one more time. Let me give 1 more minute. Okay, then we'll see.
I don't think I can do it. I don't
So
know
how did you start this question, Nasir?
I put like 00043 and then like 10,99943, like the highest and lowest numbers.
No, first Nasir is saying that the first, how many of the first 10,000 positive integers, right?
Mm-hmm.
So that means that the numbers up from 0 to 10,000.
Yeah.
So now let's just go step by step. Now, if it is so, then the first 43 appears in what number? In two-digit number, right?
Mm-hmm.
So that is 43. In two-digit numbers, we have only such number, right? 1.
Yeah.
Okay. Now the second case. And how about among the three-digit numbers? 43 may appear in the first two digits, right?
Mm-hmm.
Or in the second two digits, right? Like this.
Yeah.
If it is 43, how many such numbers are there? 10, right?
Yeah.
How about here in the second case?
10.
9.
Oh yeah.
Because the first digit cannot be 0, right? We are talking about three-digit number. And the third case is, how about four-digit numbers? It may appear like this, 4, 3, 2 numbers here, or it is 4, 3, right? Or it is 4, 3, right?
Yeah.
So in this case, the first one, 4, 3, how many such numbers?
100.
100, right? Okay. In the second case,
99.
99. The third case,
98. Uh, 98.
no, actually, why did we do a 99? Is it 99? It's 90 right here.
Oh yeah.
It is 9 choices for the first digit and 10 choices is 90.
Yeah.
And how about the last one, Nasir?
89.
Very good. Because 43 is already used, right? It is 89.
Yeah.
So then what is the total number of such numbers?
Um,
1, 10, 9, 20, 100 plus 20, 120, 210, 299, right?
yeah.
Okay, good. If I ask 43, it's a bit easy question. If I write 4, 4, we can try this. It will be harder question. Exactly the same question if I ask. How would you answer? Do it as a homework. How many of the first 10,000 positive integers contain the digit pair 4, 4 and 4, 4?
Okay.
Okay, you can try. Okay, homework and let's see what you get. Next question. Read question 22.
Each of the 1,000 ping pong balls is labeled exactly with one of the counting numbers 1, 2, 3, dot, 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 998, 999, and 1,000. Each ball has a different number. If the ping pong balls are selected at random, what is the fewest number that must be selected and set aside to be to be certain that some of the numbers on two of the selected ping pong balls will equal 1,005?
Each ball has a different number, and the ping pong balls are selected at random. At random.
Mhm.
What is the fewest number that must be selected and set aside to be certain. That's a key word, to be certain that the sum of the numbers on 2 of the selected ping pong balls will equal 1005. Yes, Nasir, have you ever solved this kind of question before, similar to it?
No, I think I might have, but I don't really understand it.
Hmm?
I don't really understand it.
You're standing here,
Mm-hmm.
and now you have a kind of bag, okay?
Yeah.
So now we have a lot of balls here, right?
Mm-hmm.
How many? 1000. Okay. Now the question is saying that if the ping pong balls are selected at random, just for
Yeah.
the selecting, right? Now, what is the fewest number that must be selected and set aside to be certain? That's a keyword. A lot of students, they don't understand that. What do we mean by to be certain? To be certain means that without looking at my bag, I can tell you exactly that in this bag, there are 2 balls where the sum of the numbers on them will be equal to 1005. And my actual decision is based on the deduction, right? The logic. It's not, I'm not checking this one by one. Because of some calculation, I can say exactly that. It like, for example, let's say, actually, for example, if I ask this question, how would you answer? What is the fewest number of students to be in the same classroom? Okay.
Mm-hmm.
So that's to guarantee that, okay, let's say, or to be certain that, or to guarantee that, to ensure that there are at least 2 students, so they were born in the same month.
Mm.
What is the fewest number of students to be in the classroom? To ensure that there are at least 2 students that they were born in the same month.
12?
No. Because if it's 12 now, sir, it is possibility that everybody was born in different month, right?
Yeah.
So then it's not 12 then.
13.
It is 13, right? And this is
Yeah.
called pigeonhole principle in math, because I'm just actually thinking we should consider the worst scenario here. If we have 12 people, there's possibility that all people were born in different months. But now if we just add one more person, right? That person must be born in one of the 12 months, which means that now actually one cell contains 2 people. So if it is 13 nothing, I can tell you exactly, even without checking, asking the people, I can tell you exactly there are 2 people at least. Maybe it is 3, maybe 4, maybe all of the people were born in the same month. I can tell exactly 2 people were born in the same month. You got it?
Yeah.
So now in this case, if you just think the worst scenario, okay? So the first ball is, what is it? The worst scenario is the first ball is 1. The second one is 2. The third one is 3. dot, dot, dot. And here I have 500. Now, if you just pick any two numbers, right, from 1 to 500, the sum is not equal to 1005, right?
Yeah,
And now our next one is 501.
it's 500.
Still, and 502,
Is that
still not right. If I just add here 503, now I know that it is 502 and 503. The sum is 1005, right?
yeah.
So in this ball, actually, among this 1000 balls, if you choose 503 balls at randomly, it doesn't matter how you choose. I can tell you exactly because I'm 100% sure that there are two balls at least. So their sum is equal to 1005. We may have maybe four balls, okay, or maybe six balls. I mean, two different pairs or three different pairs. But I know that at least two balls, their sum is 1005.
Okay.
And what is the most actually beautiful case here? You just choose the first number, it is 502. And the second number, ball, it is 503. That is possible, but that is, the most beautiful case, right?
Mhm.
Okay, so that's why the answer is 503. It's about pigeonhole principle. Let's continue. 23. Read it.
A square floor is completely covered with non-overlapping 1 by 1 white and 1 by 1 black square tiles. The tiles along the two longest diagonals are black, while the remaining tiles are white. How many white tiles are there? And if the completed floor contains 61 black tiles?
You get it?
Yeah.
Just example for 5 by 5. What's the question? How many tiles are there if the completed floor contains 61 black holes?
Uh,
One more minute, Nasir.
mhm. Is the answer a whole number?
Yeah, it must be a whole number because you're talking about the number of white square tiles, right?
Oh, yeah.
Why is it taking so long, Nasir?
I'm just thinking about it. I think I got it though. uh,
Yes, Nasir.
I don't know.
Look, in this example, if you just consider this 5 by 5 floor, right, or grid, whatever it is, you see the longest diagonals. How many black tiles are there here?
9.
It is
Oh,
9.
yeah.
How do you know that? It is 2, because if you just move this tile to the left, right, and this one to the left, and also to the left, and this one to the right, one is missing here. So there's 2 times 5 minus 1, right?
Yeah.
Actually, this 5 is just another coincidence. Actually, this 5 is the side length of the square. Is that right?
Mm-hmm.
If it is so, then in our case, then if it is 61, the 61, it should be equal to 2
Oh,
times n
I
minus 1,
I
right?
was overthinking it. I got 361, 961.
Hmm.
Wait, 961 minus
If
30.
it is so, what is n
Um,
here? That n should be equal to
is it
31, right?
is the answer 930?
No,
Oh,
it's 900s. Because here to find the wide circles, right? So it is 31 by 31 square, right?
yeah.
So it will be 31 times 31, right? These are the total number of tiles, and remove black ones, right?
Oh, yeah. So 9, yeah.
So black ones, it will be equal to 900. That is 900. Okay?
Mm-hmm.
All right, let's continue. We have 2 more questions. Let's finish it then. All right, read the question.
The shaded region shown is the area which lies both inside of right A, B, C, and outside 3 sectors formed by the arcs of the radius 3 centered at the 3 vertices of ABC, which side of triangle ABC are 7, 11, and square root of 70. The area of the shaded region is P minus Q pi. Find the integer value of P minus Q.
When the sides of triangle ABC are 7, 11, and square root of 170, the area of the shaded region is P minus Q times pi. And find the integer value of P minus Q. That's also a really beautiful question. I'll give you some time now, so think, okay? 3 minutes, you can draw quickly. And the most important thing is, will you have a right idea to solve it or not? Nasir, what do you think?
I can't figure it out.
I can give you one hint. All of these
Yeah.
sectors, right? The sectors. See that? Let me just label this. I can just, let's say this one is sector, what is it? S1, and this one is S2 and S3. If I just write, it will be a bit messy. Let me just write this. Okay. And now if I answer this question, so the angle A plus angle B plus angle C is equal to what?
Mm.
Hmm?
Angle A, angle B is 180.
180, right?
Yeah.
Do you have any idea now?
Yeah.
That means that if you just combine, right, these three sectors together, they form what?
Semicircle.
Yeah. If you combine them, they form a semicircle, right?
Mm-hmm.
That is the first one. Maybe actually it's the first one, right? And then the second part. That's it. And now if the area of the shaded region is S, what is S?
S is
1 over 2 times AB times BC, right?
yeah.
Minus the area of the semicircle, right?
Mm-hmm.
Now, what is the area of the semicircle? It is 1 over 2 times pi times r squared, right?
Yeah.
That's it. 1 over 2. What is AB?
Um, AB is 7.
7. BC, 11,
Yeah.
right? Minus, and here we have 9 over 2 pi. Or let me just simplify this. That is 77 over 2 minus 9 over 2 pi, right?
So 77 minus 9 over 2.
Yeah. P
Um,
minus q pi.
the answer
So
is
now we need to find,
34.
yeah, P minus Q. What is P?
70, no.
77 over 2,
Yeah.
right? Minus, what is Q?
9 over 2.
Which is equal to 68 over 2, and that's equal to 34, right?
34. Yeah.
So that's why this was a really beautiful question of 34. But of course, if you don't see that, you cannot solve this question. It's really hard.
Yeah.
All right, one more question, then maybe we'll finish the class, okay?
Mm-hmm.
Give me the question.
The lattice point is a point where the with integer coordinates. Straight line segment is drawn between points A -6 -5 and B 24 19, including endpoints. How many points on the straight line segment AB are lattice points? Hmm. Is it A and B also count as lattice points?
Yeah, it said including the endpoints, so including those points. Yes, Nasir.
Is there 5 lattice points?
5?
Yeah.
No. What did you do in the first step here?
Found the slope.
Slope, very good. Slope is equal to 19 plus 5 divided by 24 plus 6. Is equal to 24 over 30, right? Or by 6, it is 4 over 5. Okay, which means that is positive, right?
Mhm.
So negative 6, negative 5, if let's say our point starts here, it is point A, negative 6 and negative 5. So slope is 4 over 5 less than 1. It is something like this, right? So this one is B.
Oh, I didn't count the
24,
first one. Okay. So is it
9,
6?
7.
Oh, okay.
How should we understand this slope? Actually, you know, the slope means that, Nasir, it is the difference in y or change in y over the change over x, right?
Mhm.
And now if you make a table here, so this one is x and this one is y, right? So your starting point is negative 6, negative 5, negative 6, negative 5. And how should we understand this? It means that if you move 5 units, right, in the positive direction of x-axis, then you need to move 4 units in the positive direction of y-axis. It means this, right? Slope means this. To stay on the line, if you move 5 units, they have to go up 4 units. 5
Mhm.
units, 4 units. 5 units, 4 units, right?
Yeah.
So that means that now here we are adding plus 5 and plus 4. Negative 6 plus 5, negative 1. Plus 5, 4. Plus 5, 9. Plus 5, 14. Plus 5, 19. Plus 5, 24. So I reached that point. Now here negative 5 plus 4, negative 1 plus 4, 3 plus 4, 7 plus 4, 11 plus 4, 15 plus 4, 19. So all of these points are on this straight line, on this actually line segment. So how many points are there on this line segment where both coordinates are integers? We call them lattice points in math. There are 7.
Mhm.
Okay?
Oh, okay. Yeah, yeah.
Good, very good. Nasir, I enjoy teaching you, and also yeah, very good experience and knowledge. So don't waste it. Step by step, I hope you'll get what is it? A lot of experience and also improve your problem solving skill a lot. Now, also have a good day. I'll see you next Wednesday.
Mhm.
Okay, 9
You too.
o'clock. Okay, see you.
So,
Assalamu
see you.
alaikum. Yeah, bye bye.
So,